Hi everyone. So in the last video, I explained the definition of first principle calculus. Just a quick recap. So the first principle is to allow you to find the derivative of a function at a given point. So if you missed the video or you're not sure what's happening here, please watch the video again. So in this video, I will I will go through a few examples so you can have a better idea of what it is and how to apply them. So we're just going to start off with a basic example, 2x, and I would like to find the uh, derivative of this function. So to start off, we need to write f dash of x to indicate that we are finding the derivative. You can either write f dash of x or y dash. It's okay, whichever works. Then make sure you include this limit. So you are saying that I'm taking the limit of the function from h going to 0. Now, I'm just going to rewrite this formula again. Over h. Now, in the next step, I'm going to start to substitute that into my function. So the way it works is that you look for where the x is, then you replace that by this x plus h. Okay, so it means 2x will become 2 times x plus h. Okay, and my f of x is the same, it's just 2x. So just rewrite that, all over h. It's a bit annoying that you have to keep writing this limit from h going to 0 all the way down. But anyway, so I'm gonna just basic algebra skills here. So I'll just expand it out, and I'll get 2x plus 2h minus 2x all over h. Okay. Keep in mind that. Sorry, I'll just let it say that later. Before I move ahead, I'll just cancel it out first, and I'll get 2h all over h. So keep in mind that by the time you do the cancellation, you should be able to have the terms with only the h associated with that. So let's say I have, by this step, I still have an x somewhere here. Then you should know that you probably made a mistake somewhere in the previous steps. So you have to go back and check for that. Okay, so in this case, I've done it right. I've got on the x gone, just the h alone. Then here, I'll be able to cancel the h, which leave me just 2. Okay, so that means the first derivative, or the first derivative of the function f of x is 2. Okay, so let's move on to another example. Just to another paper. So let's say I have something slightly different. X plus 2x squared. Okay. Now, I'm just going to start off by writing similar stuff as before. So f dash of x, limit. Okay. F x plus h minus f of x all over h. You don't have to rewrite this formula the whole time. It just I'll just do it just to in case you forgot what the formula is like. Now, as I said before, you look for the x, then you replace that by x plus h. But this is quite a special case because you can actually factorize it. which means you can put these two terms contain the x, so you can just move the x outside, which leave you inside the bracket just 1 plus 2x. So quickly double check, when you expand it out, you get x and 2x squared. Okay. Now, because of that, you have two options. You can either just do it that, so you substitute into this formula, so you substitute x by that, or you use this function, so you substitute into here and here. So if you stick with this way, what it looks like in terms of x plus h is that x plus h, oh, I should just write it here for you. So x plus h 1 plus 2 times x plus h. Okay, so you look for the x, then you replace that by x plus h. Okay, and then minus f of x. So f of x is just that, so I'll just rewrite it. Okay, or if you want to go with this function, then what it looks like when you replace that by x plus h is that, so I'm replacing this x by x plus h plus 2, again replace x by x plus h all square, minus f of x. F of x is just that, so but because there's a minus in front here, so I have to put the bracket around it. All over h. Okay. So by the time you are done with the substitution, then you just have to expand it out in order to cancel them. Cancel all the x term out. Okay, so x plus h all square, that's the perfect square, just in case you've forgotten. So when you have a plus b all square, then the formula is that you square to a square plus 2ab plus b square. So my a is x and my b is h, so I'm going to have x squared. 2ab, so it's just 2xh, and b squared is just h squared. Minus, so there is no square outside the bracket, so I'll just have to bring them out of the bracket, and because there's the minus, so plus becomes minus. Okay, again all over h. Okay, so you have limit h going to 0, x plus h. Now I'm going to start bringing all these guys out by multiplying each of them by 2. So 2x squared plus 4xh plus 2h squared minus x minus 2x squared all over h. Okay, so the limit h goes to 0. Okay, so I'm going to look for something that I can get rid of. Okay, so I found this guy and that guy. 2x squared is gone. I think that's, oh wait, I still have the x here, so the x is gone as well. That h, I think that's it. Okay, so just rewrite what I have remaining all over h. Okay, limit, we're almost there. Okay, oh wait a second, I think I've made a mistake somewhere. Should be, oh no, I just wrote it the, I just miswrote it. Okay, so 2h squared. Okay, it looks good. So by this step, you see how each of these terms carry the same element, the same h. So what you do is you factorize it. So you bring the h out the front. Then what in the bracket will be 1 plus 4x plus 2h. So quickly double check. When you expand it out, you get the same thing. So you got h, you got 4xh, and you got 2h squared all over h. Okay. Now, because that's a product, right? So you are able to get rid of that and that at the denominator. So limit h goes to 0. This is what you have left. So this will be a little bit different to the example before, because you still have the h left, right? So what you do here now is that you say when h is equal to 0, so what it means on the graph is that you are saying I'm shifting this x plus h to this point. So this is when the x plus h is equal to x. So I'm shifting this from this point to this point where I am trying to find the derivative. Okay, and because when that's equal to that, the h has to be 0. So that's explain why. Okay, and the reason for doing that also is that we can get rid of that. So any h remaining will be equal to 0, which leaves you 1 plus 4x as the derivative of the function.